Okay. So we're delighted to have today with us in our Bar-Ilan University Vision Science online seminar, Professor Meike Ramon from the University of Lausanne. Meike Ramon is a cognitive neuroscientist and neuropsychologist. Her work focuses on face processing in individuals with normative visual functions, as well as those in the two opposite extremes, those with impaired face perception functions known as prosopagnosia or face blindness, and those with exceptional face perception skills known as super recognizers. She's an assistant professor and Swiss National Science Foundation Prima promoting women in academia fellow. She founded and leads the Applied Face Cognition Lab, and since September 2023 directs the Cognitive and Affective Regulation Laboratory at the University of Lausanne. She has attempted and achieved what many of us cognitive scientists do not focus on doing, taking our science into the practical real-life arena. Meike has successfully taken her research and advanced it into application and policy. She's for many years a scientific advisor for the Berlin police and has co-developed the Berlin test for super recognizer identification, also known as Be Sure, which is an important tool involving authentic police material. She's also a founding member of the 500 Women Scientists in Bern-Fribourg, a local node leader of the Swiss Reproducibility Network, a member of the European Association for Biometrics, a member of the European Platform for Experts and Europol Data Protection Experts Network, an expert panel member for InnoSwiss, the Swiss Federal Innovation Agency, and a juror for the German National AI Competition. She also organizes for some years now the AFC Lab Carla online talk series. So without further ado, Meike, we are very pleased to have you today with us to tell us about your exciting research, and thanks so much for joining us.
Thank you so much for this very elaborate introduction, which I did not provide. I'm very surprised at the level of detail and up-to-dateness too. So yeah, I really appreciate that. Slightly longer than I feel comfortable having, to be honest. Okay, so yeah, thank you everyone for being here. I'm not exactly sure who's going to be joining us. Therefore, I'm going to be giving a little bit of background or basic knowledge because my assumption was that we might be achieving a more diverse community of listeners today, given the very topical nature of this talk today. So I'll be talking about deepfake detection performance, so human-based deepfake detection in super recognizers and police officers. Okay, right. So just a little bit of background on myself. In general, I study visual cognition, so perception and memory, using different types of methods, because I was always interested in a range of different questions, which then obviously require different methods to be used. But the red line of my work, the common aspect of it, was that I was always dealing with or interested in face identity processing, specifically how individuals differ in their ability to process facial identity, both inter and intra-individually. And so I've really always tried to have this applied aspect of my work when studying the full range of this FIP skill, as Sharon already said, from prosopagnosia until over the past 5-6 years, my lab has been looking more into the superior ability side in these so-called super recognizers. Essentially everything between both extremes I've kind of studied and tried to understand what makes us different and the commonalities that we share. And so, yes, currently my lab is still funded by a Swiss National Science Foundation grant, which was amazing. And I think probably also successful because it was unique in that it really combined different stakeholders from policy and government to basic and fundamental science. And what is very common to our work is that we use different types of, I don't know why my volume was on, that we use different types of work, different types of methods, and from psychophysics to electrophysiology, but that we always have kind of an applied perspective and trying to design experiments that translate into real world or ecologically relevant scenarios. So to give a very brief overview of the talk, I'm going to be talking about three things: face identity processing and individual differences in FIP, super recognizers, or SRs for short, and how we identify them in the lab and professionally. And then lastly, how this translates to deepfake detection performance, which is going to be increasingly relevant for all of us, regardless of where we are on the ability spectrum, because due to advances in generative AI, we are increasingly confronted with a broad range of synthetic material, not only in the visual, but also auditory domain. And I think it's very challenging to verify authenticity already today, and it's no doubt going to become even more complicated. So let's start with face identity processing. So for those of you who maybe study other things or are maybe in the visual domain, but not necessarily focused on face identity processing, perhaps you may have heard, but for a lot of researchers, face identity processing is considered the pinnacle of visual perception and cognition. And this is for a number of reasons. On the one hand, newborns already show a preference and orient preferentially towards face-like stimuli, and they have also been reported to recognize their mother within 48 hours after birth. We know that face identity processing scale is highly heritable, so a lot of the variability between subjects can be genetically explained. And we also know that individuals are typically very stable when it comes to face identity processing, and that these stable behavioral performance patterns are associated with stable neural patterns that reflect this ability. And more importantly to this talk, I really want to bring home the message that we have different levels of processing facial identity, which we exploit, but sometimes also kind of gloss over, because all of these different processes that we do with faces seem very effortless to most of us. So to give you a quick idea of what I mean, when I show you these three images here, you see very quickly that there are three faces present. So that would be the first processing stage of detecting the presence of faces. But beyond that, you can also discriminate that these are different people. Not all of these images do not display the same person, but they're unique identities. Then finally, or pre-finally, if you might recall the top image, it was actually one that I showed you in the grid on the second slide. So that's your ability to recognize previously encountered identities. And finally, if you were personally familiar with me, you would recognize that the bottommost picture is actually me as a baby. So this goes to show what we can do with faces, provided that we're familiar with them or we have become familiarized with them. And this is really cool as vision scientists, because it means that we can use the same stimulus to study different types of processing levels. And these processing levels are associated with different cognitive demands. So some of them can be achieved based on visual perception alone, whereas others require perception and memory, so something additionally on top. Excuse me. And what's also important to note is that these different processing steps or processing levels are differently impacted by changes in image variations. So while detecting the presence of a face is quite robust across most of us, across most individuals, discriminating identities, recognizing and identifying them is considerably more difficult, and that's where individuals tend to differ more. So to make things more complicated, on top of these individual differences across processing levels, we also find intra-individual differences even within and across processing stages as well. But what we know is that unfamiliar face processing, although we typically take it for granted and we think that face recognition in general is the pinnacle of visual cognition, in reality, unfamiliar face processing is actually very difficult. And what we are very proficient at is processing those faces of people that we know personally. Yeah, so familiar face processing is what humans are typically quite good at. So unfamiliar face processing, on the other hand, is very difficult. And to bring this home, I just wanted to quickly show you this. So if we take, for instance, different tests of unfamiliar face processing, we did this in a 2020 study where we had 6 different tests, all testing face perception. and face recognition. And we just took neurotypical observers who didn't have any special skills and were just healthy volunteers. What we would find if we rank these people according to their overall performance across all of these tests is that there is no reliable pattern of similarity between individuals. What you would expect normally is that people who were ranked closer together, that they should show similar profiles, but that's not actually the case. So if we look at the highest and the lowest performing people here, and we look at their radar plots, where the individual dimensions are the different tests that we use, what we can see is that regardless of your ability, so regardless of how good you are, we all have individual profiles that can be assessed with different tests, and that there's no systematic relationship in terms of our performance on tests and our ability overall. So people are very different, and different tests test different things. And this makes it very, very difficult to actually understand the complexity of unfamiliar face processing. But what we do know is that there are certain individuals, these so-called super recognizers, who are consistently better. So regardless of which type of tests you show them, they are high performers in many of the tests. So they show this increased similarity that we don't see across the neurotypical cohorts. So this already brings me to the second point of super recognizers. And for those of you who have not heard of super recognizers, that's maybe not surprising because it's actually still a fairly young subject matter. In fact, the first ever study, or the first study that introduced this term super recognizer was in 2009, when Richard Russell, Ken Nakayama, and Brad Duchenne reported less than a handful of individuals who they kind of accidentally found while they were developing tests designed to assess developmental prosopagnosia. And what they found was that there was this group, or this very small group of individuals, who showed superior discrimination, recognition, and identification for facial identity. So this is just one of the plots from the original paper, and it just exemplifies where 3 of these individuals laid relative to a fairly modest control cohort. But what these 3 individuals excelled at were tests tapping into identification. So the before they were famous faces tests, where you had to recognize images of publicly known individuals, such as those displayed here. Or you had to learn previously unfamiliar faces and then recognize them in an old new context under increasingly difficult visual conditions where information was gradually removed. Or you had to perceive the facial identity of a target and kind of sort images that were morphed along an identity continuum according to the similarity of the target. So overall, these 3 processes were the original targets of the superiority that super recognizers were reported to demonstrate. What happened after that in the studies that followed was that there was actually there was no consensus regarding what makes a super recognizer. There was no formalized definition. And what's more, people used a range of different tests, applied different criteria to these different tests, and sometimes, very critically, in my opinion, also used inappropriate tests. Tests where we know that developmental prosopagnosics achieve normal performance, and these tests were then used to identify so-called super recognizers. So that's obviously a problem, and that led to a lot of heterogeneity in the findings that were reported by the time that I entered the field. So I was kind of at a crossroads thinking, well, I find this very interesting, but it's kind of a hot mess. Do I want to pursue this? And so I thought, well, okay, the least that I can do is try to provide a framework for my own work so that I know that the people that I'm testing are comparable and that they're in fact really superior based on the original or inspired by the original study. So this is this diagnostic framework that I proposed in 2021, in which I also introduced the first 70 cases of lab-identified super recognizers. So the tests that I used, according to this framework, it was the most difficult tests that were known to me at the time being. It includes 2 tests of perception and 1 test of recognition. And the first test of face perception you can see here. So this is just an example. This is not, in fact, the real material. But imagine that you have cards or images displaying individuals of the same gender, and you are supposed to decide how many unique identities you see here. So in this case, you have 15 images of brown-haired females, and your task is to put all the images together that you think belong to one person, and separate those from the other people. And so this is a task that is very difficult if you are not familiar with the people who are displayed. So I don't know if anyone has their microphone unmuted, but if anyone is willing to take a guess of how many identities are actually amongst these 15, be my guest.
2.
Yes. I wonder if that person who answered was familiar with the test, because if yes, then that makes the test much easier if you know the target identity number. But in any case, this was a test where these super recognizers are actually confronted with 40 images, and they very quickly separate them accurately into 2 groups. And we know that for neurotypical observers, this is quite difficult. The second test is actually my favorite task, and thanks to Brad Duchenne, I came across this. This is the so-called yearbook test, where you have to match images like the ones on the top, so younger versions of people, and find their corresponding match on an array of images that shows people 25 years older. And this was actually a test that was created by Maggie Brooke and Patrick Kavanaugh when they went to their 25th year high school reunion, and they took advantage of that real life scenario. And then finally, I also used the Cambridge face recognition task, the one that was also used in the original study that I had just described, which is a test of learned face recognition under old new recognition conditions. So if anyone is interested in kind of a summary of the last 5 years of my lab's work, you can find it in this hopefully soon to be accepted paper that you can already access as a preprint. And yeah, in a nutshell, what we report, or what we think to have found, is this, what I call the trifecta of super recognizers' innate superiority. So we know that super recognizers, for some reason, have a natural tendency to rapidly detect and orient towards faces when they're embedded in complex scenes, and even if they don't know whether and if where a face will be present in a complex scene. So it seems that their visual system is somehow tuned to face-like stimuli. We know that they show very consistent face discrimination performance, regardless of the information content that is available. So we did a lot of psychophysical studies with them, looking at whether they would selectively process different types of spatial frequency bandwidths, for example, better than neurotypicals. That was not the case. What we find is that they are very consistent regardless of the information that they have. And then lastly, we think that their hyperfamiliarization can be attributed due to the fact that it seems that when they're confronted with a single view of an unfamiliar face, it appears as though they're able to extract an invariant representation. And this is actually what makes them more proficient also when it comes to unfamiliar face matching. So this is kind of, in a nutshell, the behavioral work. We also have some electrophysiological findings, which I allude to in that paper, which will hopefully be published soon as well. So that brings me to the second part of this talk on how we identify super recognizers. So I've just told you about the procedures that we use in the lab in my group for lab-based super recognizer identification. But of course, this bears the question of, what's the utility for real world applications? The tests that we design in the lab are not necessarily specifically tailored to meet certain real world requirements. Excuse me. And so when all of this started, I was actually contacted by a police agency back in 2016, before we had any of this work. And they were interested in using, or they were seeking the help of these super recognizers to try and support their investigation of 2 armed robberies and burglaries that were committed in Freiburg. And what I did back then was I kind of advised them, and I put them in touch with the super recognizers, and because of the fact that we didn't have a lot of data that was available, I leapt to the opportunity and requested that I be able to use this forensic police material for scientific purposes. And fast forward 6 years later, and I think over 100 observers later, we recently published this paper, which was the first ever report of the real world utility of lab identified super recognizers. So what happened was we had these two crimes that were committed, and we had lineups of suspects. And after the cases were solved, I still continued to acquire data so that I could see whether lab identified face identity processing performance would actually predict people's forensic perpetrator identification. And in a nutshell, we provided the first evidence to suggest that there is actually a significant advantage of these lab-based super recognizers when it comes to forensic perpetrator identification. However, I also have to say that there is a large degree of variability even within super recognizers. So people also differ amongst each other in the high performing end. And I think that's really important when we think about personnel selection for deployment. Because it's one thing to have a large group of individuals who on a group level excel relative to neurotypical controls, but it's something different when you are the head of a unit and you have maybe 2 or 3 super recognizers, and then you need to make a decision based on their estimates. So these are some of the things that I would just kind of add to the overall advantage that we observed. Kind of at the same time, so this was actually in April 2017, the Berlin police contacted me because they were interested in finding super recognizers amongst their circa 25,000 employees. And what had happened was that in 2016, there was a terrorist attack on a Christmas market where a terrorist stole a lorry and drove into the Christmas market, killing several and injuring several people. And what happened was that then there was a special or a designated unit that came together. It was, I think, 60 to 80 people or so who were supposed to view recordings from public places and try to find the perpetrator based on images such as the ones that you see here. And as I think you will be able to easily imagine, this is an impossible task. Unfamiliar face matching under these very, very difficult conditions in such a wide search area that is not even entirely covered with CCTV footage is just daunting and impossible from a statistical point of view even. So what happened was they got in touch and they were interested in finding super recognizers, and they essentially wanted to know if I had tests and if I could help them. And at the time being, I said, well, sure, I have a lot of tests, but, oops, sorry, I kind of advanced too fast. I have tests, but at that point, we didn't know whether the tests were good predictors of what they had in mind. So instead of giving them access to or selling my tests, I said, maybe think about what exactly do you want them to do, and let's design something that you can use to explicitly find the people that you want to then put in those real world tasks. So what we did is we conducted a lot of expert interviews within the entire organization and identified the most critical areas of deployment for super recognizers within that organization. And then we built a test battery that was started from a very simple task to a nearly impossible task to really make sure that we identify people who are consistently better across all these tasks. And so this is the Berlin test for super recognizer identification, or BeSure for short, which was really a participatory research action. So together with detectives, we developed, designed, piloted, and then also reported this. And we think it's a very useful tool because it involves authentic police material, and it was designed for and with the practitioners who are going to be using it. Actually now, in April, the first year pilot of the super recognizers that we identified will come to an end, and we'll have a post deployment evaluation. So that's really exciting. So in short, what this test entails was, as I said, we started from something that was simple and that we thought everyone would be able to do, which is a one-to-one matching using ideal image materials. So mugshots where people are fully frontal, high resolution images, nothing difficult about it, just a standard identity verification task with ideal material. Then we increase task difficulty in two different ways. A, by changing the statistics. So basically chance level kind of decreased because we used a 1 to 10 matching scenario. And on top of that, we had different flavors of this 1 to 10 matching task, where we had people either match mugshot to mugshot, so relatively easy, mugshot to wild images, so images from CCTV footage, or wild to wild. So you can imagine that these three manipulations also further increase task difficulty. And in the final stage, I thought this was going to be an impossible task because I really wanted to have something that everyone can do and something that no one can achieve. But of course, the super recognizers surprised me. In this crowd search, we had people we presented people a target identity, which was sometimes also a wild image. And they had to look for this person really in wild footage, for instance, in public events such as sporting events, soccer stadiums, etc., where they were dealing with a lot of image degradation, fans waving, rain, a lot of people wearing the same jerseys, low resolution. So this is the kind of scenario that we created. And most importantly for me was that these non-matching distractor images, so essentially all of those that are not the target, but the distractors, those were selected using an open source algorithm, face recognition algorithm, and we specifically chose the false positives that this model would have provided. So by design, we are finding humans who do not make the same mistakes as the open source algorithm that we used for the distractor selection. So I think that's very important because by definition, we are finding people who don't make the same mistakes as algorithms do. And for later deployment and also fusing algorithms and humans together, I think that's really important. And so, yes, this is kind of the scenario that you could imagine, searching for a given target that's unfamiliar to you in a 1 to 3 minute video clip, such as the one that I just showed you. So this is work that's still currently under review, where we, for the first time, wanted to compare how do these lab tests compare to the real world performance. So we had invited the 18,000 officers to perform the lab tests that I previously presented to you, and we got a fairly large volunteer rate, participation rate, so about 10%, which was a delight. And then these people were then further invited to conduct the B-Shore tests, and they would, upon successful completion, be then invited to do the next phase. So it was 3 phases of B-Shore, and first people performed the lab tests. So this was the first ever time that we were able to systematically and directly compare how these lab tests compared to real world performance across this range of increasingly difficult, authentic tasks. And what I'm showing here on the right is the Z-scored performance across all of these individual tasks. So what you can think of is every single data point is one observer's performance across all of these 5 subtests here. And what we can see is that those people who did not meet the lab criteria, which are displayed in gray, are on average less proficient in B-Shore than those who did meet the lab diagnostic criteria for super recognizers. So in short, the lab identified super recognizers in dark do perform better than the non-super recognizers. However, if you look across these different subtasks individually, again, light showing non-SRs, gray, dark gray showing super recognizers, you can always see that super recognizers seem to outperform non-super recognizers, but there are actually always notable differences in such that there are individuals who we maybe incorrectly label as non-super recognizers, but who consistently perform very, very highly in these professional tasks. And we can see this across all of these authentic tasks as well. And very, very intriguingly, there was one subtest where we did not find an advantage for super recognizers over controls, and that was the only test where it involved wild-to-wild matching. So here it was, again, just to recall, you had an image of a target that was not ideal, so that was not high resolution, that was also from a CCTV footage base, and then you had to compare it to non-ideal CCTV footage as well. So what this suggests to me is that I think even super recognizers require a veridical high-resolution image of a target. At least one good image needs to be present or available for them to derive this invariant representation, which then lets them proficiently match even across bad viewing conditions. So I think this is really important when we need to consider these group differences, whereby we did find a super recognizer advantage in BB Sure, but we also have to be aware that, you know, we might be missing out on people who show very good professional task-based performance, even though they don't meet the criteria that we pose in the lab. So now I'm just going to take a quick break and ask if there are any questions in between before I get to the last part, the reason why you're here about deepfake detection.
Meike, I mean, I do have questions, but I will leave them to the end because it's not specifically related to these. I mean, it is, but it's more of a discussion.
Okay, awesome.
Yeah.
All right, then I will just proceed. So I guess then the question arises, we see how super recognizers perform in the lab. We now know how they might perform or do perform in real world scenarios. But all of this involved material that actually stemmed from genuine humans. That's natural information. And, you know, with the advent of generative AI and the rapid improvements that are being made there, the obvious question is, well, is there any advantage for verifying the veracity of information through super recognizers? And this is actually something that I thought about when I was attending VSS virtually, and Matt Groh was presenting a talk on deepfake detection performance in humans, in neurotypical humans, prolific observers or organic traffic that him and his colleagues at the MIT Media Lab had gathered, where they were presenting these deepfake stimuli. Sorry. Okay, so this is the study that I'm going to be talking about, and we are also hopeful that it will soon be published, but the preprint is already available. So, so as I said, this was inspired by the work that then was later published by Matt Groh and his colleagues in PNAS, where they took like a wisdom of crowds approach, and they were comparing human to algorithmic performance in detecting deepfake stimuli. And I'm not going to go into all of the details of the study because it is very greatly described in their very, very clear study, which I can only recommend to read. It was a great delight. But in short, what they did was they took material that was submitted for the Facebook deepfake detection challenge, which essentially consisted of videos that had been that involved face swapping through deepfake autoencoders at different resolutions and using different types of techniques and model approaches. So using the exact same stimuli that he had presented to his organic or prolific recruited observers, we wanted to conduct the study in super recognizers and the Berlin police officers. Because one thing that was unique to their study was that the observers who participated or provided data never saw the entire set of stimuli, but they were always shown a random draw of, I think, about 25 stimuli. So it was not necessarily the most in-depth observation of a given observer, but it was more a wisdom of crowds approach to see in general how across 15,000 observations or observers, people are able to detect deepfake material. So I said, I want to take a full experiment approach and present all of the stimuli to all of the observers who are willing to participate so that we get a better understanding of their face identity processing abilities and whether or not it relates to deepfake detection performance. So we used the same two experiments that Grow et al. Had used before. On the one hand, we had a 2 alternative force choice experiment where people saw or were presented with 2 videos, and they had to decide which of the 2 videos was a deepfake and which was not. And they could play these videos at their own will. There was no time constraint. They could pause, they could rewind, etc. Basically interact with the videos as if they were viewing something on YouTube. Or they were presented with a single video and they had to indicate whether they thought it was a deep fake or whether it was not. And they also provided certainty indications of like how certain they were. And we performed 3 different types of analyses on different data sets. And so now I'm going to go through these 3 different analyses and data sets consecutively. So the first thing that I was very, very interested in was, oh, I just hear some audio. I don't know if someone. Yes. Okay, so I'll just start again. So the first question was that I asked myself was, is there going to be a speed accuracy trade-off? So if I take more time and elaborate more, interact more with each stimulus, will this lead to better overt deepfake detection performance? This could be an indicator of motivation or people paying closer attention and picking up on details that might be diagnostic for detecting a deepfake. And so here we really took advantage of the full gamut of data that was available to us, including the original Grow et al. Data, even though their observers had only been presented with a subset of the stimuli. But we also invited previously identified super recognizers that I had reported a couple of years before, as well as all of the Berlin police officers who were invited to and completed the entire Be Sure subtest range. The second type of analysis, we were really trying to categorically compare. If we group people or identify people as super recognizers and non-super recognizers, can we find some kind of an advantage for super recognizers if we take this dichotomization approach? So if we just perform these analyses in a categorical manner. And for this, obviously, we needed their super recognizer status. So here we focused on the data of the previously identified super recognizers as well as the Berlin police officers, because again, to recap, they were previously invited to complete all of my tests. And then the third analysis was a continuous analysis where rather than looking at people and assigning them labels, what we did was we ranked people according to their composite scores on Be Sure to have face identity processing ability as a continuous variable and relate this to deepfake detection performance to see if there's any systematic relationship between face identity processing ability measured very sensitively using Be Sure and deepfake detection performance. So to the first analysis, this is going to be very quick. There was simply no speed accuracy trade-off, meaning that it is not such that people who took longer were not better. In fact, in one of the 2 experiments, in the 2 alternative force choice, the longer you took, the worse you actually performed. So it seemed as though either you pick up on the differences that can rapidly discriminate which of the 2 is genuine or synthetic, or you don't, and then you lose yourself in the details. So there was no indication for a speed accuracy trade-off. And if anything, people showed a tendency to decrease in terms of the performance the longer they took.
Meike,
In the second, yeah.
Sorry, can I ask, were super recognizers or the super recognizers you identified, were they actually faster? Not only, I mean, I assume they were also pretty good in accuracy, but were they faster?
No, I don't think so, because that was exactly the point where I said to Matt, we have to look at the reaction times. This is really important. But no, it didn't seem to be the case. Yeah.
Thank you. Thank you.
Okay, so we didn't find any difference in terms of speed and accuracy. However, then the second interesting analysis was this categorical analysis where we were trying to compare super recognizers to controls and essentially just binarily grouping people. And here we looked at the different experiments, and what you can see is that for the two alternative forced choice, it seems like super recognizers and non-super recognizers are doing pretty much the same thing or are performing in a very comparable manner. And we also didn't find any differences for the single video experiment. So this didn't really seem like there was any systematic relationship between group status and deepfake detection performance. But I thought, well, we know that those people who we identify as super recognizers in the lab are not the only ones who are performing well in Be Sure. So maybe we just need to take this finer grained approach and look at ability in a more continuous fashion. Okay. And again, to recap, we had these 5 individual subtests for Be Sure, and here our analyses focused, of course, then only on the Berlin police officers. Whether or not, so here really we did not consider anyone as super recognizer or not. So here we just blindly approached them saying, based on the composite scores across all of the 5 Be Sure tests, if we rank these people according to their composite scores across all the subtests of Be Sure, you can see that the lower performing individuals have lighter colors, whereas the higher performing individuals have darker colors. And then we wanted to see where these people align on the deepfake detection performance experiments. And in both the 2 alternative forced choice as well as the single video experiment, we do not find a systematic relationship between ability and deepfake detection performance. In fact, if you look closely, you'll see that the lowest performer was maybe the worst on the 2 alternative forced choice, but the lowest performer in the single video was actually a high performing Be Sure observer. So that suggests that there is no relationship between face identity processing as we measured it and human deepfake detection performance. So to summarize, we did not find any speed accuracy trade-offs. We found no advantage for super recognizers, and we also didn't find any advantage for ability more generally and deepfake detection performance. So as of now, we have no advantage for super recognizers and deepfake detection performance. And I say as of now because there are, in my opinion, at least 2 important caveats. First of all, as I said previously, we showed them videos with unlimited presentation duration. So people could explore, rewind, and do basically anything that they wanted with these videos. We were not able to pick up on which information they were selectively sampling, regardless of how long they were sampling or inspecting the image material. People also had the ability to zoom in. So you can hit Command+ and really focus in or just leave it as it was presented to you. So we didn't have any control of how people were interacting with the material. That was, again, dynamic. So it was videos that we presented. And so far, super recognizers, were tested with identity processing and not deepfake material, but they were always tested, with exception of one subtest, with static material. So you could also maybe assume that provided dynamic information, even people who are lower performers might perform comparably when it comes to simply deciding whether something is synthetic or not. And of course, that would then be independent of identity processing ability, because what you're picking up on is motion cues that seem to not be in accordance with what our brain expects from natural statistics in an environment. And another important caveat, of course, is that, unfortunately, we are always kind of behind. As soon as we have stimuli that are generated from a competition and we're using them in a study, by the time that it gets published, you can always make the reviewer 2 argument that the stimuli that you're using is not state of the art. And certainly, I would agree that if anything, this deepfake stimuli that are probably, if the competition were to be redone, would probably be only more difficult. So I think the jig isn't up. We still don't know whether with state-of-the-art generative models and using static images under more controlled condition, potentially there could be a difference depending on people's ability, or it might just be that verifying synthetic or natural images has absolutely nothing to do with identity processing, that these are in fact independent things. But I think that we need more controlled experiments to definitively answer this question. But it was very interesting because there was a lot of interest and motivation, and I think we already did the right step in kind of accruing these important cohorts, because in fact the people who participated, our observers, are the ones that are going to be professionally tasked with making these decisions on whether something is in fact a deep fake or not. And even if we can't find an advantage, and there is none to be found, I think it's an important way of engaging with the people who are held responsible and have to do these things. And it kind of creates a scenario to interact with these different stakeholders on these regards. So yeah, that's the end of my talk. And in case there are some people around who want to read more about this, there's more publications on our website. And I just kind of threw a couple of them that might be interesting here on this slide. And otherwise, I'm really happy to take any questions. And thanks for your attention.
Thank you very much. I'm asking everybody to unmute yourself to give a big thank you and applaud for Meike. And Shlomit has already asked two questions in the chat, so I don't know if that's even possible, but I'll read them anyway. So can you please play an example of the deepfake versus natural video? That's one, and I'm not sure you have that accessible. And the other is, was there any feedback given to the participants regarding their performance? Is there evidence of deepfake identification is something that can improve with training? And yes, I'm seeing, yeah.
Okay, so to the first question, whether you can see the videos, yes, you can. I think that Matt, he's now at the Kellogg School of Management at Northwestern University, but I think he's successfully migrated his organic participant thing. And my understanding is that the images are still there, but they're also accessible. Anyone can access them. There's a GitHub repo that he is also referenced in the 2021 PNAS study. So everyone can look at them there, or you can contribute to the data that Matt is still acquiring. The second question, it was, sorry, regarding training?
Yeah,
feedback.
Was there any feedback? And is there evidence that deepfake identification can improve its training?
So we did not provide feedback. I definitely did not want to do this. And I believe in the original study, there was feedback. I did not want to provide feedback because I just simply thought of myself, if I get feedback and it's wrong 6 or 7 times, I will likely drop out. And I simply wanted to get as much data as I could from individuals and rather give them their performance at the end. So we didn't provide any feedback. There is one study, the author names of which now I cannot come up with, but I can look this up and send it to you afterwards. I know that there was a study that said that even with training, people seem to not improve in terms of being able to detect deepfakes or not. And I think this makes sense because, some deepfake stimuli are quite obvious and others are not very obvious, and telling people to look at the things that are maybe not obvious and maybe simply not perceptible would not necessarily lead to performance. And also deepfakes can vary. There are different types of techniques for creating deepfakes, and telling someone that in this particular instance, this is the feature that's diagnostic, that might not hold for the next deepfake stimulus.
Two more things before I get to my questions. Steve wrote, thank you very much for a fascinating summary of your research. And Joseph Borders wrote, along this line, I'm wondering if we have a grasp of a face-relevant diagnostic use. Actually, you probably answered that. To differentiate deepfake from real, I'm aware that other cues that do not involve faces. Okay, I'm aware of other cues. Okay, so you basically said that You just answered that, I think.
No, yeah, so it could be, but in these particular deep fakes, because they were this deep fake detection challenge where they use these face swapping autoencoders, I don't know all the technical details, but here all of the manipulations were faces where it was maybe individual features, or maybe it was an entirely generated face. Yeah, so it was always face related, but within the face, there were different types of things that could have been manipulated.
Lovely. I want to ask, because I sometimes get, images, and I try to find, I mean, knowing they're probably deep fake, or, I mean, apart from one that was on Twitter, which people had to judge if it was or wasn't, but I try to find what, where is the deep fake information, let's say, and I have to say that I'm looking very closely at very, very, very minor issues like the ears, the background, all the stuff in the hair. And so it's very, I mean, if you think about it as a technique or an algorithm, it's very much going into local features rather than having like a global gestaltic kind of, the face holistic processing. And my thoughts are that maybe super recognizers have, their expertise is in the gestalt, kind of like, the holistic processing, rather than going into I mean, they would recognize a person even if they probably, wore different earrings or colored their hair, or so maybe it's not those very local minor details that can differentiate deepfake from actual authentic images. And maybe that's why they don't show no benefit, because it's,
Yeah.
I would even predict, if this is true, then prosopagnostics would also do almost the same.
So this is precisely the reason why we reached out then to Brad and Hani Farid, and we wanted to do the full spectrum of ability to say, well, if this holds, it should extend, or maybe we'll find a reverse pattern in the developmental prosopagnostics. But just a quick question to the deepfakes that you're referring to. Were you referring to videos or static images when you were picking up on
I was
local...
referring to, but it's not, it's just, there's this person does not exist, and all these,
exactly.
platforms you can get deep fake as many as you want, and just so I'm challenging myself. It's not an experiment that I was participating in any way, but
No, but I think so, because this is exactly, that was like the genesis of my thought process when I approached this as well. But then I realized very quickly that the images that we look at from this person doesn't exist, or here's 1,000 version of Obama and it's all not him, or something like that. And yes, when you look closely, you can see, oh yeah, this person's right earlobe looks wonky relative to the left or something like that. But these are typically they're not even state-of-the-art generative models anymore, is my understanding. But let's say they were the ones that were maybe in, say, 2019 or so, that were researcher-created generative models. And I think that the results that they produce are, again, fundamentally different from something that's commercially available, because the training data sets that we use that then are the basis of whatever is then synthetically generated will lead to different types of probabilities of certain diagnostic features occurring or not. So there's actually, so there's a real big difference in terms of what is the underlying training set that was then used and what's the output. So if you just compare state-of-the-art generative deepfake or generative AI-based deepfakes that are created for research purposes, people who are dealing in biometrics, that creates a totally different image than, say, Midjourney creates based on text user prompts. It's like there you wouldn't be able to detect that. So even just using the term deepfake does not give justice to all the variations in terms of the quality and the types of deepfakes that we see. So I think that's another factor. However, I have to say that these videos, it was really challenging, also because of the fact that the face didn't take up so much space. The images that I showed, it was oftentimes people interacting or performing some kind of task, and the face space occupied a very, very limited area in the visual field, which is also different from how we test people with their face abilities in the lab. So I think these are all these caveats we have to address in further studies. So yeah.
So basically, you're also saying that even if you had found some diagnostic features, it may have just been, you know, let's say database or algorithm specific, and it could possibly not have generalized to other deepfake generated stimuli. Interesting.
Can I
in
follow
another...
up on what you were saying, Sharon?
Yeah, sorry.
First of all,
Sure.
first of all, Mike, I really enjoyed the talk. I wasn't aware about super recognizers. I think it's a fantastic a phenomena.
Thank you.
But following up on the deepfake, there are studies that can recognize deepfake. I mean, again, they're AI-based deepfake, so something is there. Okay, so the information is there, and there was a study quite a while ago that tried to show this was more of a generative and not it was gun-based. That doesn't matter. Things that happened that were really changing were really minor, but they were really consistent. So they were always at the edges or always at certain places. So again, following up on what Sharon was saying, could be that the super face recognizers are not tuned to these specific changes, but maybe there are super, text tone recognizers or super scratch recognizers, or maybe you can even detect them based on how well they do on these deepfakes, and they would perform better because they're tuned to these changes. I mean, the information is there somehow. It might be either below our acuity ability, but if they're there, they're not necessarily in the realm of facial variations, right? It's something at a very low, like signal at a signal level.
Yeah, I agree. I mean, again, kind of what I said to Sharon, it's again, if there are features that algorithms can pick up on, it's likely because these features are commonalities that are reflected in the training data sets. Because if there was more variability, then you wouldn't be able to consistently use that feature. Like, outline, or the fact that they're always full front smiling, slightly turned left, or something like that. As soon as there are features that, whether it's humans or algorithms, can pick up on, it's very plausible to assume that this is a reflectant property that is inherent to the training data set. So this is, I guess, on the one hand, why if we want to have algorithmic support for deepfake detection, we need to ensure that the training sets were most diverse, so that we're not only picking up on certain features that will then easily be overridden in the future. To your point, as whether we can identify some kind of superiority, regardless of how we call it, based on the deepfake. Absolutely. I mean, that's kind of that's the ideal approach. We don't need to understand how a dog hound picks up a trail to believe that they picked up a trail and they got there. For me, that's the only thing that counts. Yeah, whether or not I can perceive it or not. So yes, I'm sure that there are.
Did you find in your test, in your subject pool, anyone that was specifically very proficient at detecting?
Well, we didn't look at that specifically, but I believe that because of the variability between the different types of deepfakes, it would not be likely to assume that there were individuals. And I think on the last slide that I showed, where I was comparing the Be Sure, so the police continuous analysis, with the two alternative and the single one, there it was kind of all over the place. So I wouldn't assume that it's worth digging that deep into the data. I think a better, in my opinion, or maybe a more fruitful or promising approach would be to have different types of deepfakes. You could basically have them chronologically ordered so that it reflects the development of the tech or the training data sets that have contributed to it. So you would assume that the more diverse the training sets, the more time progressed, the more difficult the deepfakes. And then if we show that, then we can say, well, let's take the most difficult ones and find the people who are good no matter what. But I think we need more stimuli, because we just simply didn't have that range of diversity that I would be comfortable and certain to say, here's a person who's really good at deepfake detection.
Yeah. Cool. Thank you.
Thank you. Oh, we can't hear you, Sean.
Yeah, sorry. I wanted to ask, there are two more issues in the chat, if you're happy to take them also. Shall I read them to you?
Of course, yeah.
Okay, so Chen Reshef has asked, hi, was the facial expression also generated in deepfake, such as facial expression of emotion? So I assume so, but it's better that you actually relate to
Yeah.
that.
I believe so, in those where maybe the facial expression was manipulated, but there were also naturally occurring changes that were just, when two people were interacting, talking about something, there was a whole plethora of things that could change, yeah.
Okay, lovely. And there's an okay, I hope so. Were this is Mohammed Muzamil who's asking, were the stimuli hallucinated by AI, or were those face swaps? Did the stimulus contain unknown identities? Given that SRs are recognizers, would you agree that it would be better to test on known individuals or previously seen individuals, i.e. in real images, and discriminate the generated face swapped images from real ones for those same individuals?
Okay, so Muhammad, thanks for the question. Awesome to see you or see that you're here. If you can just first of all tell me what you mean by hallucinated, because I don't know whether the face swapping via the encoder that I mentioned corresponds to what you believe to be hallucinatory. I don't know
Yeah,
if you're
sure. Hi, Meike.
okay. Okay, if your answer, yeah, sorry.
Yeah, can you hear me?
Yes.
Yeah.
Okay, so what I wanted to ask was basically you can generate images like this person doesn't exist or something like that that do not exist in the real world and are not from any data set, or uh, could be like coincidental that they are similar to a real individual, or it could be just face swap from a real individual. So what I wanted to ask was that since super recognizers are recognizers, would it make a difference if you have completely generated identities versus the identities of people who are real, but their
Yeah.
faces are put on different individuals, or let's say like someone else? And
Yeah.
would it also make a difference if it's face swapped in the second case? Would it make a difference if the identities of the people are known prior to the experiment for the super recognizers? Like, since they are recognizers, would it make a difference like if they already knew the people, whether they are celebrities or someone they had already known or previously shown in the real images prior to the experiment? I think it may make a difference in my opinion, but you would have a better idea. Thanks.
Yeah. So with regards to the first part of your question, then okay, so I need to break this down. Sorry. So super recognizers, as I said in the beginning, and maybe I wasn't, sufficiently clear, the way that I identify them is both superior performance on perceptual and recognition tasks, or only on perceptual tasks. So you can qualify in different ways. And the Berlin police test, there it had nothing to do with recognition. So that was purely perceptual. So I think that I'm tapping more into people who have superior perceptual tasks. And some of them might also have superior face memory as well. So I don't think that this necessarily is an answer to your question, or that it's a knockout feature that nullifies the findings. And I don't know that it would change fundamentally if we used deep fakes that involve face swapping of known identities, because this would stipulate that people have not only an acute representation of their face, but that they are also familiar with the mannerisms and the dynamic, say, I don't know, gestures and other types of behavior, nonverbal cues that accompany identity as well. So I don't know whether that's so relevant. I do know that some of the trials actually involved, like there's a Kim Jong-un, there's a Trump, and there's a Biden. There's a couple of trials, but I think these were like 5 trials, and everyone was presented the same ones, and it's not sufficient trials to look at whether there's a systematic difference. However, I don't know that this is. It's an interesting question. I don't know whether it's the one that's most pressing to me, because I believe that the majority of challenges and risks that are posed by deepfakes, at least to the general population, are, I don't know, revenge porn, people using your identity and showing it to people who are not personally familiar with you. So it doesn't, the recognition of the identity, who is being swapped or who has been swapped, is maybe not the most pressing issue. It's the fact that we need to pick up on whatever feature it is that would be a giveaway that it's not genuine. So yeah, I feel like I maybe have partially answered your question and maybe opened a couple of new doors or confused a couple of people. I don't know.
Yeah, I think you did. I think you answered the question. Yeah. I agree that this might not be the most pressing question, but I was coming from the angle of whether there would be a correlation between the performances of recognizing deepfakes for known identities and the performance of super recognizers, like compared to the current results that we have. And yeah, that's where I was coming from purely.
Yeah, again, I think because of the fact that we identify them predominantly based on the perceptual skills, I don't think that that question holds in this particular instance.
Great. Okay, thanks for the answer.
Thanks.
Meike, I'd like to thank you very, very much for joining us for a really exciting talk. And again, thank you so much for your great talk. And hope to see you soon somewhere around the globe.
Yes. Thanks again for the invitation and for all your questions and for
Our
taking the time
pleasure.
out of your. Okay. Bye.
Thank you.